Hi everyone, in this video I will tell you what is convolution neural network, how can we install it, and a simple example. First, let's make an introduction to what is CNN. CNN in deep learning is often used to analyze and detect visual images. So who was the CNN found by? We cannot say that CNN has exactly found by someone or invented it. It has become today by making changes over time. However, Fukushima used the first CNN structure in 1960s. He inspired by works of Hubble and Wiesel. Of course, CNN structure has changed a lot later. Why do we need to learn CNN? The big data, which have named as a result of the data explosion, has both computation complexity, but the real issue is not just the big data. Now we expect more from the data. At the point we reached, it was understood that it was necessary to extract different information from the data in the order to calculate billions of parameters. The motivation requires for the solution of problems such as image classification, object detection, object training, natural language processing is again based on neural network. For example, when we upload an image to Facebook, would you like to take person X makes a proposition? So did you concern how do you know that person? Or have you ever thought how Google's image search algorithm works? There is a neural network behind all this. Let's talk biology behind the idea. CNN used unique feature that turn an airplane into an airplane to distinguish the image provided. In fact, this process happens unconsciously in our brains. For example, when we look at an airplane picture, when we identify the plane by separating the features such as two wings, engines, and windows. CNN does the same, but previously they detect low-level features such as curves and edge and create them up to more abstract concepts. In this video, as you can see here, CNN is taught that these pictures and objects are cats. Finally, CNN is shown a picture, a cat, and CNN guess is it a cat? It is a cat. Yes, we showed and it guessed. The system works this way. To understand CNN, we need to know its structure. To achieve the functionality, we talked about CNN process the image with various layers. We will examine these layers in detail in the next section of the article. In the next slides of the article. But now just give an overview of these layers and their purpose. Convolution layer use the detect features. Pooling layer reduce weight, count, and check convenience. Flattening layer pre-requires data for the classic neural network. And the last one is fully connected layer. Standard neural network use the classification. Convolution layer. This layer in the main building block of CNN, responsible for perceiving the characteristic of the breeze. This layer applies some filters to the image to remove low and high level features in the image. Now let's take a look at how the filter is applied. Firstly, the filter is positioned in the upper left. And the first one is we look at the upper left. And the matrix is two-dimensional, image and filter. Image and filter are multiplied by each other and all the results are summed. When we look at the first one, 1 multiplied 1 is 1, 1 multiplied 0 is 0, 1 multiplied 1 is 1, 1 multiplied 0 is 0, 1 multiplied 1 is 1, 0, 0, 0, and 1 multiplied 1 is 1. So when we sum all the 4 1, it will be 4 and we will write there is a 4. So what does the output matrix tell us? The matrix is often called feature map, by meaning the filter over the image and using the simple matrix product. We detect our properties. Pooling layer. The task of this layer is reduce the shift size of the impressions and parameters and the number of calculations within the network. In this way, incompatibility in the network is checked. There are many pooling operations, but most of the popular is max pooling. Let's go by explaining this process over the figures. As you can see the picture, the filter gets the largest number in the area it covers. Let's look at the first one, 7387, and the largest number is 8, and we will write there 8. In this way, it issues smaller outputs that contain enough information for the neural network to make the right decision. Flattening layer. The task of the layer is simply to prepare the data extremes of the most important layer. Fully connected layer, generally neural network receive input data from a one-dimensional array. The data in the neural network is the one dimension of the matrices from the convolution and pooling layer. As you can see there, there was two-dimensional array and it converts one-dimensional array. The last one is fully connected layer. This layer is the last and most important layer of CNN. It takes the from data the floating process and performs the learning process via the neural network. The role of the CNN is to take this data and combine the features into a wider variety of the attributes that make the convolution neural network more capability of classifying image, which is the whole purpose from creating a CNN. There are CNN architecture. The architecture of a CNN is a key factor in determining its performance and efficiency. The way in which the layers are structured, which elements are used in each layers, and how they are designed will often affect the speed and accuracy with which it can be preferred a previous task. In this video, I will not describe the architecture in detail. I will show you some important and widely used CNN architecture. The first one is ResNet and AlexNet, GoogleNet, and VGGNet. We can also say it's VGG16. There are things to know before you start learning CNN. As I explained, CNN structure works with the matrix. In order to understand better, it's necessary to know linear algebra, calculus, and statistics. Also, in order to implement CNN, it is necessary to know at least one object-oriented language. And to understand the algorithms in CNN, data structure and algorithm issues should be known. It is CNN example. CNN is used in many areas where data is available. For example, in the medical field, brain tumor detection. This is the, as you can see, this is the brain tumor detection. And breast cancer detection are performance will be help of the CNN. At the same time, it is used in many areas such as face detection in social media, fingerprint system in the office, and language interpreter. Which platform mostly used for CNN? Some libraries for implementing CNN are shown in this table. It's also started in which language these libraries and frameworks are used. For example, TensorFlow and Torch are widely used in CNN. Also, these libraries are written in Python. In this video, we will learn to download and use Python. I shared two links here. When we click the first one, and also we click here, you can install Python on your computer. And when we click the second one, and also you can click the download button, you can install PyCharm. Before we do an example, you have to download these and after that you can continue this example. Our example is digit classification CNN for MNIST. I will show you MNIST dataset. It seems like that. MNIST dataset using the Keras API and creates a plot of the first 9 images in the training dataset. And we will make an example. First of all, we imported Keras libraries here. We imported Keras libraries here. After that, we load MNIST data, and we separated train and test data from whole data. And these are CNN implementation. We created an object of sequential model here. After that, this step, convolution step, this step more easy with Keras library. We took an object which already has an idea of flow or our neural network is going to be. Then we added convolution layer by using con2d function. This function taking 4 parameters for arguments. The first one is 32. Its mean 32 is the number of filters, and the second one is the shape each filters, and the third one is activation function, and the last one is input shape. After we want the pooling operation on the result feature maps, we start by taking our classifier object and add the pooling layer. We take 2 multiply 2 matrix. We will have minimum pixel loss and get precise region where the features are located. After that, it's time for us to now convert all the pooled images into the continuous vector through flattening. We have used flattening function to perform flattening. We have used we no need add any special parameters because Keras will understand that the classifier object is already holding pooled image pixels and they need to be flattered. And the last one layer is fully connected layer. To this layer, we are going to connect to set of the nodes we get after the flattening step. These nodes will be act as on input layer to this fully connected layer. As you can see, densa function is the function of the add a fully connected layer. Unit is where we define the number of nodes. It is the unit that should be present in the hidden layer. And the last argument is activation layer. After that, it is initialize our output layer, which should be contain only one node, with dense function, as it is being classification. Now that we have completed building our CNN model, it's time to compile it. These are compile codes. And the last one is accuracy and loss. Let's look at our example results. This loss is 0.03, and the accuracy is very high. If the accuracy is 1, your CNN is very well. It has to be near to 1. Accuracy has to be near 1, and the loss must be near 0. And it's all. This is implementation CNN, I told you, and it's over. To summarize, we learned in this video that CNN is a deep learning network used in many different areas. We also learned that it can be implemented in different environments. I hope this video has been benefits and understandable for you. Thank you for listening.